Good evening, everyone. Hope you all are safe and doing well. Excel in Excel welcomes you all. We are back with a new fresh talk this weekend. Thank you all for enrolling in this event. We welcome you all. I also take the privilege in welcoming Dr. Paul K. Jayakar, who will be addressing us in the next few moments. Let me give a gist of Excel in Excel. Excel in Excel is a data analytics firm that solves high impact business problems using data and technology. We provide end to end services in the field of data analytics and data visualization. Our core services include analytics, consulting, and training. Excel in Excel presents the popular talk show EiEFreshTalk on its YouTube channel, where it hosts great leaders and subject matter experts in various fields from India and abroad to speak regularly on variety of topics ranging from Excel to analytics and finance to financial modeling and much more. Few of our past events are Decision Making in Uncertain Times by CA Vijay Kumar Sir, Internal Audit During Uncertain Times by CA Satya Praveen. In our past session by CA Satya Praveen on internal audit during uncertain times, he did highlight that business are facing newer challenges on account of working from home, data privacy, and cyber security. To address all these issues, we have an eminent personality amongst us, CA Dr. Paul K. Jayakar, who will help us to understand the fundamentals of web security, latest emerging attacks facing the internets, and much more. We welcome you, sir. I take the privilege of introducing our guest to the audience. Dr.
Thank
Paul
you
Jayakar
very
is
much.
a fellow member of the Institute of Chartered Accountants of India since 1981. He holds the professional membership with ISACA and the Institute of Internal Auditors. He is the Director for the Information Technology and Risk Management Services as CNK and Associates LLP Chartered Accountants. He is on board of governance of IIA India Chennai chapter. His experience includes internet security, system design, system architecture, technology design, information system audit, forensic audit, data migration audit, CAAT audit, enterprise risk assessment, fraud risk assessment, data analytics, data visualization, standard compliance, ERP architecture design, infrastructure management services, cyber law compliance, software remediation, and ITIS related regulatory compliance. He is a reputed teacher who has been teaching for past 30 plus years in a variety of subjects including management, IT, and related areas. We welcome you, sir. Before we begin, I request the participants to join me in welcoming today's speaker with commenting a hi in the chat section. For any queries or comments, please use the chat section. We will present it later to the speaker. Over to you, sir.
Yeah, thank you very much. So right now on the screen, we should be able to see the. Okay, we should be able to see the slide which says Web Services Security.
Yes, sir.
Okay, if you're all able to see it, it's fine. So that should be fine. Okay, now I'll just get started. So, let me give a very brief introduction before we get started. I try to put as many pictures as possible instead of a lot of text. So if you look at the what we are trying to look at today, it's not a very it's more a macro level understanding of the problems which these web services bring to us. They're very convenient. I mean, it's a very convenient thing, but any new technology brings its own problems and its own set of headaches. So when we look at the requirement of these web information, Web was originally started in 91 or 92 with Tim Berners-Lee writing his HTML. That's all the history part of it. It was mostly used for static web pages. Then it went to dynamic, and as of today, we actually run this web services as a software a solution itself. A small part of business logic, a larger part still being somewhere else in the server. A small part of the business logic, and we do a lot of transaction processing across the internet using web services. So just as a background, when the internet was developed, when it was released, 1980s, the early 80s, NSFNet and internet, there was no web as such. There was no HTML as such. There was no HTTP protocol. I mean, it's difficult to imagine what they did, but they did use things like chat, IRC protocols. They used FTP, Telnet, and so on. But they did not have this HTML till much later, in the early 90s, when this was introduced. So for most of the younger people who may not know that the internet existed without these web pages, that was how the internet worked. So there was not a lot of research did not go into this web concept. It's a new concept. So I mean, talking about the 90s. 80s was all the concept of remote access and so on. So a lot of protocol development went on there. Now, of course, we are trying to work with more and more protocols, but you must understand the foundation of the internet is already fixed. We are just building on top of it. So I've just broken this up into three pieces where you have a quick introduction, a very quick introduction. Then we'll go to the vulnerabilities and how do we battle them. I'm looking at this more from a auditor's perspective or a security analyst or a security advisor's or risk advisory perspective. There may be not much of technology, but if you have any questions, please do ask. I put in a little bit of technology, but it's, I mean, you're free to ask questions if you wish to. So the first thing I want to tell you is that in terms of problems on the internet, these are all taken from, actually, though it says semantic, I've taken all this from the Government of India's presentation at Delhi. So if you look at this table, we find that in terms of targeted attacks, of course, the numbers are smaller, maybe one third or some close to that, a little more than that. But India is immediately after the US. And if you look at the blackmailing targets, that's ransomware detections, we are in the fourth in the list. There we are pretty close, maybe just less than half of what US gets. Now, we know there are a lot of issues here without getting into politics. India does a lot of work for other countries, a lot of software work, and I mean, a lot of work. So we do a lot of back office knowledge, banking operations, and some of them may be secret also, like what the army does and signals and so on. Some of it may be like not secret but confidential, like banking. For instance, Citibank does a lot of work here. The scope is the Standard Charts, global operations, etc. So we do know a lot of work happens. You know, World Bank's back office is here in India. So we know that India is way up, fourth for ransomware, and CDS got hit, and India is second in the targeted attacks. Why are we there? Because obviously we are a fast developing nation, and we are somewhere three on the economic growth. More growth brings more problems. So then the point is, it brings more business opportunities also to those who are working on this security. Then we also need to understand who is actually causing this trouble. Now we need to look at these are, I mean, many things here. We may be working with government companies, or we may be working with the government itself, or you may be working with private companies which are global. You may be working with Indian companies which are global presence, or pure Indian companies. So, and systems are connected up to banks, insurance companies, logistic companies, seaports, a whole lot of things. We call them interfaces or web connections or whatever. So EDI. So there's a lot of networking going on, including your phones, with your web mails and so on. So one is, of course, the basic thief. I mean, he's a hacker, and what he's trying to do is he's trying to study the systems. He's basically a vandal. I mean, he's breaking things. He's not too serious about what he's doing, but he may sell things also. It is possible. But generally, the whole world is not only in the hands of hackers. It's also in the hands of people who are like pickpockets and thieves and bank robbers and so on. So it is in the hands of what you call cyber criminals. So this is another, in fact, cyber criminals take a lot of information from these hackers and then they use it to make money. Then we have a lot of people who are like, self-proclaimed, like we have NGOs here who keep protesting against things. We have people who keep protesting, and one more form of a protest is bringing down web services, or shutting down connectivity and so on. But it's a smaller group, but a little difficult to say whether it's a hacker or a hacktivist. So it's a bit of a little difficult because many hacktivists hire hackers to carry out this destructive activities or cause disruption in services. Now we have a small group. This is hard to prove, but very safely it says North Korean. But as you know, today we have at least India faces threats from Chinese and Pakistani hackers. That's just from the countryside. But when we say Nigerian and so on, it may not really be Nigerian. It may be just they're using their IPs, or see, for instance, sometimes some security auditor says I traced it to a university in Spain or Portugal or Austria. Obviously, a university guy is not going to do it. They just put some software into the university's machines, and that university machine is causing trouble to other users. But the IP exposed to the investigators is the university's machine's IPs. The other people have just hidden themselves behind that. This is state sponsored, difficult to trace, but we need to know this because it's not here. But we have something called cyber warfare and cyber terrorism. If you have time on Google, if you see Estonia, Estonia, is the first country which was brought down purely by bringing down their network and dependent services. Then we have a lot of malicious insiders. Again, a little difficult to prove because um, insiders also have outsiders helping them collusion. We could have a lot of difficulties here in tracing. Unlike a physical crime where you could actually catch people, insiders, when they cause mischief, it's a little more difficult, though we have a few cases of insider trading being detected and so on. That's if the theft of data, but if somebody was causing trouble, like emphasis when the card data was stolen, we need to look at insiders as a threat. Generally, we say insiders is the maximum threat, but that's because only that gets reported. The outsides don't get reported, but we know that state-sponsored and cyber criminals are much more than insiders. But it may be a nexus. It's called social engineering, or it could be a collusion. Then we have people who accidentally do things. These are the large volume of employees, people, students, different people, and old people who are chatting with their um, children or grandchildren abroad. And there's a whole lot of people who are just innocent victims, and they also become a part of this attacks on some system or the other. Percentages you need not take them seriously, but categories we can take them seriously. So if you look at the non-malicious insiders, you need a lot of training. The others, of course, we need a lot of protection. And this is also taken from the government site. Actually, this is, what this very simply says is, over the years, what has happened is there are a lot of people doing research. Honest research. It's not bad research. It's good research. So they have been publishing their findings and a lot of things they've been doing by writing books, maybe like taking webinars or whatever. But as they keep telling more and more things or exposing more and more of the vulnerabilities they have studied, the attack sophistication becomes very, very good. So you reach a stage when we are no longer bothered about simple things like viruses and hacking of websites or defacement. You're more worried about identity theft, this denial of service is bringing sites down, and today cyber warfare, cyber terrorism, those kind of things. All this is happening. A lot of it happens through, not all, a lot of it happens through web services. They can happen through other services, but other services are generally very robust. It's the web services which are not so robust. It'll improve. I mean, there are people working every day on how to improve the web services. But what we notice is this exponential growth is because when we say cyber, it is on the internet, and the largest service people on the internet are used to is the web services. Now, this is just a time period of development where in the early stages, I told you 90s, early 90s, a web page simply meant it was like a bulletin or a notice board. In fact, they used names like electronic bulletin board and electronic mail message systems and so on. So they were just like piece of notice wall posters. They sat somewhere on a computer. You looked at a web page, you got some information, and that's it. Simplest, no problem, no executable code, nothing was there. But then people wanted to go in for interactive web pages. Then they call it HTML. They call it DHTML, dynamic HTML, where you can actually enter data, like we enter some information. You can retrieve data from the servers. You could be interactive. A lot of things could happen, but yet no payment gateways and all that. This was basically submit data, retrieve data. That's all you could do. But then that itself was the beginning of the problem because you needed to write small programs, like you need to write Java applets or they had to write these Visual Basic scripts, ActiveX scripts. They wrote JavaScript. I mean, a lot of languages were developed for the HTML pages, PHP, CGI, okay, a lot of things. So that once you have a software inside, vulnerability is obviously going to come in. In the third level, what they said was it's not just interaction, it is actually execution of services, processing of data. That's how it all started with the shopping sites. Then you went on to whatever this payment gateways and so on. But then it also moved on to software. Today, most of the ERPs, even the large systems, even your web check-ins and whatever, large software, you can have mobile phone or browser-based or app-based interfaces. So it's not restricted to web content. So the words have all changed. Today, a web page is not a web page. It's actually a GUI front end. It's a screen, and you could do anything with it. You could carry out transactions. Like when we are having a webinar now, this is called a client, where you can actually log into the web page. You can see your YouTube on your web page. You don't have to open YouTube. So there are a lot of things you could do here. So today we are here. I don't think we'll ever go back to the earlier ones. Now, if you see the definition, W3C is the body which gives all these web protocols. It's called World Wide Web Consortium. They said this is a software system. They specifically used the word software for defining web services to support, and this interoperable machine to machine means today it means everything: mobile phones, voice interactive systems, your TVs, which are smart as we call them, anything right up to mainframe servers, IoTs, everything is all connected up together. And they got another thing which says you can connect to external computing resources where you have supply chain infrastructure. Generally, in a supply chain, we only think of materials, physical materials moving in and out. But today they use the word, or we use the word digital content, which includes books, music, movies, patented information, a lot of things like your airline data, your whatever railway data. Think of any data, they're all content, they're all assets, digital assets. So that supply chain, and it should be the same thing with confidentiality, integrity, etc., availability. And you have a whole lot of equipment which is taking care of this, which doesn't belong to the people who are actually part of that business. So when you're watching a Netflix, probably Amazon or somebody owns nothing there. It's T3 which does the content. Internet providers transfer it. There are outsourced companies which handle your payment gateway. Your payments. Payment gateway companies handle payments. There are fintech and regtech companies which take care of the regulatory compliances. Uh, Basically, there's no infrastructure with the company offering you these movies. And more you study, the more it's going to get common. So let's look at quickly look at some names. Don't worry about these protocols. They're all got fancy names. Now, see what happens is whenever you build something like our accounting standards or so many rules we have, like the tax rules and so on. One of the things is you got to follow some rules. Otherwise, if A and B develop some web services, only A and B can use it. C cannot use it because C's got some other set of rules. So in the early days itself, they understood and they standardized HTML, the protocol HTTP. They did a lot of at least some standardization. Then it became better and better. As today we have a lot of standardization. So these are built on when we say existing and emerging. Web research has not stopped; it is going on. We have a lot of these names. I've just expanded it for those who need the presentations. See, one is this web service definition language is a lot of rules as to how these processes, the port numbers, the services, the data structuring, all that has to be done. This is as good as writing a program in COBOL or C or something with a lot of rules in it. When you go to the detection and this, when you're talking about this universal description detection, this is when you're on the web. Sometimes you have to move around a number of machines to pick up information. So they wrote some set of rules for that, which is called the universal description discovery, etc., integration and all that. This is basically like a spider program. Early days when Yahoo and Alta Vista wrote spiders, they wrote their own logic. But now we have rules for it. I mean, how do you go around? How do you detect? How do you send the information back? Now, this is something like, okay, I need a customs clearance. All the people to see. Somebody wrote a standard set of procedures. You go to the RBI for something, you go to the customs for something, then you go to the joint controller, import, export for something. So there are some different people you would contact. You don't want to meet unwanted people, waste your time. At the same time, you don't want to miss out a required person. So that's what the UDDI does. When you come to this simple object access protocol, now we need to define an object. I just think of an object as a program or any data or program which is just bundled up. So it's like I'm trying to send you something. In the very old days, using a network, we had to send it character by character. But today you don't have to do that. When you have a attachment, for instance, in your mail, you put in a JPEG or TIFF or something, you just attach an object. So the image is an object, but it doesn't have to be an image. It can be a whole, let's say I queried data and I got 100 records. All 100 records can be packaged into a single bundle, a frame, whatever we're going to call it. I'll just call it an object. That object will be sent out from the sending machine and received by the receiving machine. There's only one catch here. The receiving machine must be able to open up that object and process it. Now, a simple example would be I send someone a file, a Word file, but the other person does not have Word on his machine. He can't open the file. So, I mean, simple example like that. Don't take Word as the object, but it can be anything. It can be a bunch of records. It can be a movie, whatever. But then we also use the other word, streaming. Streaming means we are continuously sending, real time. Object means you have bundled it up, packed it together, and send it like a parcel. So it goes as one piece. Only problem with objects, the other side must be able to make sense out of the object. They should be able to deserialize the object and make sense out of it. So, what are the capabilities of these web services? They can be anything. That's why we say loosely coupled, no strict rules, because TCP/IP plays a main role here. It's language neutral. You can have PHP, I can have HTML, whatever, it doesn't matter. Then its platform means operating systems mainly, and the web servers, and transport independent. They could be high speed networks, low speed, wireless, it can be microwave, it can be anything, or a mix of everything. And interoperability is once I send an object from one machine, a Windows machine to a Unix machine, both of them should be able to make use of that object. So these we'll just take for granted. So that's why we say the internet is more like a big fishnet across the world. Everything is connected, everything else. Tracing the connections is a big nightmare. So when we come to this interoperability, just taken images of the net. So you can have a language. C++ is a language with an operating system. ARM, of course, they are there in your telephones, I mean mobile phones also. You can have any kind of transaction gateway on AX, is IBM's version of Unix. PowerPieces are machines. You can have some kind of a billing service or reconciliation service. Mainly I'm sticking with the financial so we understand easily. So we can have any kind of transaction or data processing servers. If you notice, all of them are working through the web service. So when you say web service, it's a very wide definition. So when we do the audit or the security aspect checking of it, the most difficult part is nobody can tell us clearly what is happening. Maybe it's a, let's say, let's say an Amazon site. You get dealer, seller stuff, you get stuff from Amazon. You may actually go to a payment gateway for something that in turn will go to soft switches and credit cards and so on, companies and so on. Then you may also be sending off information to dispatch companies, some warehousing company or some computer. So somebody is checking and saying, I'm going to do a security scan or a vulnerability scan or an audit of the web service. He has to trace the services. We can do it. The software available, it can be traced. Nobody will know actually. I mean, even if you ask the company, they may not know. Part of it, see, they'll say we submit on the web. Web pages can do e-way bills, they can do ROC filing, they can do whatever. I mean, lots of things they can do. They can do the NTR, whatever, this NEFT business. How will the company know which protocol, which web page, what they're using? So we need to have some tools to identify that. Then comes the problems which have been identified and classified. See, when we say systems at risk, now let's say the risk promotion is all from the Government of India's data. One is they said, well, 67% were aided by significant errors of the victim. There is adverse behavior and management. Like we hear every day something happened, they clicked on a mail link or some SMS came, they responded to it, something like that. So, and if you notice, most of them have are already known breaches. Say 80% of the breaches, patches were available, but generally people don't install them. See, large organizations may have a policy, a security policy, but we don't have one for our mobile phones. I mean, we really don't do that for our home PCs. There's no really no policy. And a good hacker will probably enter into the corporate system from a end user or an innocent victim. That's where they get in because they know their systems are not secure. So once the vulnerabilities are going to happen, then you have systems at risk. And then the theft or whatever attack happens. Then from a system not at risk, because somebody was ignorant or somebody didn't do the patching correctly, victims are not properly trained, systems have now moved into the high risk category. A thief has exploited it, a hacker has exploited it, they become affected systems. And many of them go undiscovered. Actually, it's not weeks or months, some of them they don't know for years. Spyware sits in your system and keeps sending data out. And today, since most of our internet connections are paid by the month, not by the bytes and traffic, most of us don't even know what happens in phones and laptops. And so even in companies, sometimes firewall ports are kept open. So, okay, not blaming anyone, but what I'm saying is it's a lot of ignorance. It's like not checking the petrol when you started. It's not putting a seatbelt. A lot of things, and then something is bound to go wrong. Okay, now let's get to the actual subject of it. Now we have something called categorizations. The taxonomy here is the categorization, categories. Now one is pretending to be some other machine. That is a very common fraud which happens. You want to pretend that you're somebody else. So when I try to log into my bank machine, a page comes up. It looks like the bank's page, Axis Bank or some bank, whatever I say bank. Actually, it's not the bank's page. Somebody has deliberately redirected your URL, your address, put the wrong page and taken away data. So spoofing has become so common now that, in fact, it's surprising that there are still people who get fooled by it. So spoofing is a very common way of doing things. Because sometimes I get a message on my Airtel phone saying that BSNL wants to verify your number. What they do is they do a bulk SMS or something. Some of you might have migrated your numbers or whatever. So this guy still thinks you're in the other service provider and he's sending a message from there. It's basically a very common fraud. Now, tampering is what we are going to study a little more detail. This is modification of various things, right from HTTP requests to XML data, right up to your website and this web services definitions getting altered. This is done by, motivated people and people who really want to steal or cause trouble to the organization. Now, this repudiation part is not, it's not non-repudiation, nothing to do with certification, digital certificates. This is, we don't log the user's actions. So we don't track what people do in the organization. And if they're using personal devices, we are supposed to install mobile device management and keep tracking it, but we don't. So this is like having no speedometer on the car, no odometer, you don't know how many kilometers you're traveling, no fuel gauge, so we have no idea what's happening. We take a risk. So this is something like that. No, nobody bothers about keeping track. And today, I wouldn't simply say log users' actions. We need to have dashboards which bring up exceptions. Then information disclosure is this sensitive data has a lot of definitions. One is your code itself, CODE, your web code, your HTML code, XML code, whatever code we have written. But it also deals with the other data, like information data, like people's data, product data, and so on. India is also slowly trying to bring in a lot of laws on this wrong disclosures. Europe and US have a lot of laws, Japan and Singapore also. And then we have some rules from the company law people. That's SEBI has got its LODR and IT 2008 the rules, IT Information Technology Act rules 2008. They've given us some data to be protected. There's a lot of things in India, except it's getting bigger and bigger. And those dealing outside India must know the local rules of the other country also, because web pages are like universal. Denial of service, in the earlier days, denial of service was always a shutdown of the service. But denial of service today is not, it's not always a shutdown. It could mean slowing down responses, giving time to somebody else to do some unwanted activities. The earliest known example of this denial of services, it was between Pepsi and Coke. I mean, it's a very old management case study. I don't remember which one, but one of these companies started buying up their competitors' cool drink bottles from all the shops, and they started breaking the bottles. Coke and Pepsi are globally competitors. Only in India, the same shop sells both, but there they don't do that. So once I think Pepsi broke Coke's bottle, so something like that. What happened was they could not replenish stock because glass bottle manufacturer needed time to make the bottles. So once they smashed all the bottles, it became a denial of service to the other company. It's basically criminals don't change their ideas. It's only the methodology which changes because of technology. But basic thing is don't allow the other person to do something so that you gain that time or that window where you can do something else. Then escalation of privileges is I'm an ordinary user, like a bank account holder. I'm able to see other people's accounts. Or I'm only a worker. I enter data, but also get into supervisory rights where I authorize my own transactions. This is also because web level authorizations are possible. This also happens. And we have to go into details of each of these. Now, I just got a small picture. It's something like what you saw already. Only thing is, where are the vulnerabilities in this entire web service? It can happen at the end client, your PC, laptop, desktop, workstation, phone, wherever it is. It can also have happen in transit. That's why we say in motion encryption or in transit encryption, data at rest encryption. So while data is moving around, also it will get stolen. So that's possible. Then you have all these web services and web servers and ports and so on. Can somebody cause some trouble there? Yes, they can. Then we have the web service, binaries means again programs. So the web services themselves bring requests, which are actually serviced by databases, by logic, programs having business logic in them. They do some work. And when the deployment happens, you can unwantedly start up a program. You can unwantedly shut down a program, a service. So every point in that chain has become vulnerable now. So it's like when you go out, the risk is when you start from your house to your office, Okay, the risk is you don't reach the office on time, some tire puncture or traffic jam or something. But if you were in Africa, it's also possible your car got stolen or they beat you up or something else. So what you find is the risks have started increasing, and also the services have started increasing. So, I mean, when I say risks increase, not because of the services alone, the thieves are able to detect at the end point, at the transit point, at some points where you're entering into the service like ports and web servers. They're also able to get into the actual business servers, the business logic servers, and they're also able to control deployment. Actually, deployment has become automated. So many of you will know that slowly the jobs of administrators are reducing, and instead the administration code is written in the program itself. They call it DevOps, DevOps, because we're using virtualization. You shift instances across servers. So this old concept of a human being operating, console operator kind of thing, database operator, slowly those jobs are dying. Now, these are the various vulnerabilities. It's not, I mean, I didn't take this from a web service. I mean, the government, it's actually like an NGO, but it's part of the US government. They have OWASP, that's the Open Web Security people. They come out with a lot of data on like CERT, and a lot of people, other SANS and so on. They come out with a lot of information based on current studies. I mean, all the vulnerability hacks, what they found out, what somebody complained to them. And they came out with a list of 12 things. This will keep changing every year. They keep updating the list. So what I thought is we'll just quickly look at all these vulnerabilities to get a better understanding of where we are. So if you take this first one, which is called the brute force, it was basically used for password guessing. What happens is most of the time the passwords are easily guessed. You have dictionary passwords like something at 123, people's names, their date of birth, some basic data they're able to identify. Today with machine learning, patterns can be very easily detected in passwords. So what we say is you have bad passwords, weak passwords, I mean, not bad passwords, weak passwords. Some thief is able to run a number of passwords and guess the password and get into the system. So have we got rid of passwords? Have we gone in for fingerprints and biometric and so on? We have. But biometric also gets stored as strings. So if you want to have a real secure biometric, instead of storing the fingerprint or whatever the retina as an image or as a vector image or a set of data points, it has to store it as the ridges in your fingerprints. It's more like a CAD diagram. Your ridges in the fingerprint won't change, even if you burnt your finger or skin peeled off or whatever. The ridges in the fingerprint are much more reliable, but it's very expensive. Maybe it'll get cheaper. It takes years, but technology also, when it gets cheaper, we start using it. So today, brute force attacks can also be done for even, except when the key is very big, then it's difficult. That is first part. One is just getting access. The second part is getting access with the right roles. That's what we call the credentials. So I'm not just interested in breaking into the system. I wanted to break into the system as the CFO, or I want to break into it as the works manager or someone. I can get the right credentials also guessed and put it in there, or I have been sniffing traffic and picked up these credentials earlier, and I have used it when I did the brute force. I also sent the credentials along with it and got into the system. These are the problems which are happening. So when we say the vulnerabilities, these are problems. Next, we have to see how to solve them, how to prevent them rather. Then we have a lot of information which gets disclosed. So to make it simple, I said the code at the back end is exposed to the public. What happens is when you give a wrong command, many times you would have seen, along with the HTTP error, you will get all this information which says which web server it's running, what's the version number, which version of PHP it's using, how it's running, and so on. And what will happen is, I mean, those who know the coding part and those are up to date will know all the known vulnerabilities in these web servers and PHP coding or Perl or PHP or whatever we have written it out in, let's say, Java code or whatever. and Java is a little more difficult, but let's say the other easier ones. You're able to identify the vulnerabilities from this information, then carry out some other attack, which I'm coming to. So this is the second vulnerability. This is, I said, information disclosure. But the other vulnerability is disclosing confidential information, private, confidential, vital, sensitive, etc. That is the second part. But today, since we are on the web services security, one is we are giving away information about what type of locks we have in a company. For instance, we say we have got a Chubb safe, a so-and-so model. Then this guy knows how that lock operates. He does some study. Then he knows how to break it. So it's as bad as giving away that much information. Then we go to the next one. This is called the SQL injection. So I couldn't find a proper image. So I just put in a little bit of code. I'll explain the code. It's quite straightforward. I'll explain the code. See, what the code says is somebody has typed a command. Just forget this, leave off this website. Just go to this, where you type a command, you have clicked on something, it says gifts. The code which goes after the question mark, your search string will go. You clicked on a category called gifts. Let's say it's a shopping site. You clicked on gifts. When you did that on that web page, the HTML, this URL which went, reach the other side, the web server, and gets converted to a query. These are called SQL queries. This converts itself to select all records, I mean all columns, that's the asterisk, all the fields from a file name called products, where is the condition, where category is gifts, and they also have a status switch. That means, okay, this query is completed, so this released status is 1. Genuine query, genuine conversion. So what we said is pick up all details from the products table, the category is something, and change the switch to on. On is 1, off is 0. But now let's see how people exploit it. If you're searching also, you'd have seen on your URL, there's a question mark and something after it. Only request is that after you do all this, many of you may read more on the internet or read books. Don't hack your office sites. You can try these on. There are sites on the internet where you can actually test your skills. I suggest you use those, but don't do anything to real sites because many real sites have a lot of vulnerabilities. Okay, anyway, now coming back to our story here, this is the original code which somebody generated. The person, either the person who generated this itself or somebody who intercepted this query, was able to inject 2 hyphens, which stands for a comment. So when this, if you see, it's the same thing. Products question, this is the variable, and category is a variable, gifts is the value. But after that, you get 2 dashes, which means when it goes to the SQL treats these 2 hyphens as a comment. The line is correct. Select all the fields from table where category is gifts. But after the 2 hyphens where it inserted and released is 1, it will ignore it because the rest of it becomes a comment. So what it actually does is once it does not know it has completed the query, you can keep that query open for something else. In fact, I skipped a lot of statements here where you can pick up all the products, unreleased products, products with no price tags on them, etc., etc. Now I went right to the last one where we said 1 equal 1 or anything equal to itself is true. I mean, that's always true. So the same question, the same thing actually at the beginning. We got this products category up to gifts. Then somebody injected this extra part plus, and this or is this or that can be true. And means both must be true and so on. But the and got commented. Here nothing got commented. You're adding an or, which is a Boolean or, and you put 1 equal 1. Then after that, anything after that, you made it as a comment. So what happens now is picks all the fields from the table. Category is gifts, or instead of category equal gifts, it picks up everything because 1 equal 1 is true. The rest of it becomes a comment. It doesn't note that it has released or rather executed that statement. All the products in the database will get released. Sometimes there could be products under development, new products not released, waiting for release in a festival time or something. So what I'm trying to say is in this SQL injection, it is so silly that if on the web browser that Where you type the URL, you watch that URL, you'll find a question mark with your queries. You're able to tamper with it. The website is not very strong. I'm not talking about Amazon or Flipkart, but there are a lot of very weak websites which say search and they'll give you a thing on the web page. They'll get broken. So that's what we are meaning here. It's a very, very common thing. So we have to trap the SQL injection on the other side. Similar to SQL, let's see, that is a query. LDAP is for the directories. Now, LDAP is a protocol, lightweight directory access protocol. The protocol uses X.50500. Okay, that's the protocol they use. What is it used for? Now, when you want to pick up directories on web servers, there will be an LDAP instruction which actually keeps moving around. I don't know if any of you has got fed up with the website. You kind of backspaced your query and went to the website with just one directory with a full stop or two full stops, parent directory or subdirectory, and then all the directory dump came out. And then you clicked on the directory and did something. That's why I said don't try any genuine website. You can hack those exercise websites we have on the internet. And if you're doing an audit, of course, you hack the real website. So instead of having a username and password which goes in, picks up some information, by introducing these brackets, ampersands, hyphens, question marks, double quotes, single quotes, special characters, basically wildcard characters like asterisk and so on, you can get inside and display the directory. There's nothing real here. All these are images from the internet. If you ask me, this is also not real. It's just taken from a website. If you're going to do something real, just do it on an exercise website. Now, what are we doing? We're trying to read the directories in the web server, or if you are able to pass the web server, you can actually read it from the real server. So a lot of people have directory access, control, password, this, that, so many things they have. But by just tinkering around a little bit and introducing unwanted characters, we can actually pick up the directories of those so-called secure servers. Then we come to the next one. This is session hijacking. Okay, what happens in a session establishment is it's called a three-way handshake or a sync. The client makes a request. The server will respond to the request. It's called and then both of them will freeze the connection on it's called a port, a PORT. That's called the three-way request. So there's a request, acknowledgement, and a sync. But then there's another fellow who's actually watching your traffic through your wireless. Mainly wireless today is one of the biggest headaches. But you can also tap phone lines, lease lines, whatever. You can tap some, except fiber optic is a little more difficult to tap. So somebody is kind of listening in on the data going up and down from your machine to some other machine. Should he be near your machine? Not necessarily. This guy could be in US, machines could be in India. It doesn't matter. So you still listen. They're all based on these IP addresses and so on. So once he's able to, when your session is just authorized, he disconnects you and he puts in his machine with the same information and takes away the data. So this is something like, it's an extreme example, but you kidnap a guy, you take him to the ATM, even let's say it's biometric, you ask him to put his fingerprint, authorize the machine, type in a large amount of money. And just when the money is coming out, you shoot the guy, take the money and go off. So it is something like that. What this person will think is the connection got cut. He will try to re-log in or do something, but these transfers take only fractions of a second. So the deal is done, and by the time he logs in, his money is gone or data has disappeared or a lot of things happen. Now we have this next one, which we said was denial of service. I just took this diagram because long back, denial of service is mostly to block servers. Like it happens in your exam processing. A lot of people log into your exam sites. Same day when the result comes, the site gets overloaded and breaks down. But that here, the overload is intentional. So what the thief does is, he has got programs. These were earlier what we call programs, etc. Today they call them bots, BOTS. It doesn't matter, just names change, but they're still programs. So what these bots do is they travel through the network, infecting other machines which don't even know they've got bots on them. And at some targeted point in time, All of them keep making requests to one specified server. Server gets an overload, and the genuine user is not allowed to carry out his operations. But let us say on all these red or orange lines, one of them is a mischievous request. It compromises, picks up data from the server, comes to a really honest looking third party server, and from there it goes back to the thief. So these are like, distracting people. Like a bunch of people come to the restaurant, they distract you. Just when you're looking somewhere, one fellow snatches your phone and he runs away. So this is something similar to that. They instead of just being denial of service to an innocent person, this has also become keeping these other people on hold, doing some mischievous activity in the server, and then getting data or money or whatever it is. Now, this is another, actually, it's more in the older systems, but see, when we say older systems, there are a lot of programmers who copy code. Not every programmer writes code from scratch. They reuse a lot of codes. In fact, today the youngsters, they just copy code from the internet or from textbooks. So the problem here is when you have a program which is running, and we know from the RAM side, you get a program, there is whatever data is coming to the buffer, and then any arithmetic or any working area, that's called the heap. Heap keeps fluctuating. Now, when this program executes, etc., it does some work. One of the things it could possibly do is call a subroutine or a procedure. I use the word procedure here, just copy the picture, but it could be a subroutine, it could be an external call, could be a device driver call, because I see sometimes on these, when you open some attachment, it says on the attachment you get small icons, download, you can print. The rule is a web page cannot access local hardware. It should not read your local disk. It should not read your printer or access your printer and so on. But invariably, somewhere you will find one button to print, one button to download. When you call that, it actually moves out of the web page. There may be a security check. There may not be. That depends how your computer is configured. It makes a call, maybe internal logic, or as I told you, printer logic, something, and after it finishes the work, it comes back to the original program. But what this fellow does is, when it makes this call, he is able to increase the heap size here and push some of his own code. A code is like dynamic in the RAM. Now, the most difficult part in auditors and security analysts is that if you switch off your machine, this code will be lost. So that is why they say when your server is attacked, don't switch it off. Only isolate it from the network, pull off the cable or something, and use a dumping software like Ncase or something, forensic whatever software. Dump the RAM also, because you need to know what was actually going on in the server. So this guy makes this call, modifies the return address, and then it won't return to your program. It returns to that guy's program, or it does something else. This was a very old problem when people used to type excess characters in their input fields. Now these guys found a way to actually change the return calls itself, go back to the original program return instructions. Then we have the next one, which is called the cross-site scripting. What it means is somebody left a script on the website which is not a part of the original script. It was a fraudulent script added later. So let's think in terms of an attacker who has found a vulnerability. Vulnerability scanners you can run it online also. You can run a vulnerability scanner online. So you run the scanner, you detect a vulnerability, then you put in some fraudulent code over there. When an innocent person logs into this website, pulls out that web page or the content or whatever, it brings that link along with it, and this person doesn't know, he just clicks on it. And instead of actually sending data back to the website, the link redirects the data back to some malicious or attacker's website, or not website, like attacker's server, or who is collecting this data. Now, this is one way where money is stolen. Generally, these payment links, download links, a lot of links which sometimes you click, and if you notice anything suspicious happening, just turn off your machine. So it'll cut everything off, everything will die. Okay, these are called compromised websites. Now we have the next one. Everybody's heard of XML, this extensible markup language. Even XBRL is a kind of XML, but with tags fixed by the government or the tax department or someone, ROC. But this XML, we write our own tags, and then, I mean, you can create a DTD, a data table definition. EDI uses a lot of it. Now, the problem, same again. All these are now become code modifications. See, what happens is the hacker actually identifies a weak application. Then he gets some code from there where he's pushing in a lot of XML commands, new data table definitions. It goes to the website. Then, when there is a genuine process, it pushes that information back to the thief. Now, here is a privilege escalation. See, there's a horizontal, a vertical, etc. privilege escalations. Horizontal is simple example is one bank account holder is able to read the balances of all the other bank account holders. They're all on the same level, but he's able to breach the the wall which we have put for that, that only this person can only see his account. Kind of, he's able to see other accounts. When it's vertical, he's able to authorize or go to a higher level to do something. It's a very small example here where somebody is logging in, but he's able to breach this XML object and insert himself as an administrator instead of as a normal user. How easy is it? It's pretty easy. It's like you lost your key for your car or you left it inside. The authorized service will say I have to tow it. Roadside mechanic will open it somehow for you. So these guys are like roadside mechanics. I mean, they basically know code very well. So they inject it here. Now we also have what is called the X path injection. This is changing the path of this XML wherever it's supposed to navigate. Now the unfortunate part is on the internet, documents are picked up from different locations which you may not know. In your own ERPs, tables, the files will be in one place. The attachments will be in another server called a document server. Printing will go to another server called a print server. There's a print authorization and so on. It depends how it's configured. You don't know that, but what you do is just click somewhere and you click on the link, the attachment opens, we see the document, we say, okay, approve it, be done with it, or take a printout and go away. But the paths here are three different server IPs. It is possible one of them is in the cloud. And now I found even in the case of firewalls and UTM devices, when the manufacturer is unable to update the patches on them, they're giving a cloud IP. They're saying let the traffic come to the cloud. They have put this firewall logic in the cloud. It'll check it there, and then it will send the data to your firewall appliance. The rest of the old code is there that will still check for the old rules, and then it goes into your system. Now, what happens if the cloud of this firewall provider, Checkpoint or SonicWall or Huawei or whoever it is, if that gets compromised, everything's gone. So, path injection is possible because today things are moving across machines and without the knowledge of the person using that particular application. So the same thing here, just like you saw in the SQL injection, all started from there, start getting bigger and bigger. You give an employee ID, that has changed to true, or you can change it to false. True will pick up all records, false won't pick up any record. This is mainly to navigate to different systems, stealing data, because we had some, when mergers and acquisitions are done, they say we are leaving the financials on a secure website, which only that auditor or some legal firm can see. Maybe it's all secured, some vendor puts it in, somebody puts all the documents, the secretarial or someone, but any interested person with a little bit of knowledge should be able to read those documents. Then for this, it's a long story. These are basically web service definition language. So the definition languages are like rules, like programming, so or a DTD where you have to put the information within certain restricted things. So the WSDL components we have the part components, we have the operations components of the port type, the binding components, we have the service components. So there's a message, which port it connects to, what's the service port, and there'll be all the listening port will always start up a service port for binding, and it goes on that way. And then this, of course, we have the element types and the definition of DTD. As a small example here, we can ignore the example. The top part is sufficient. when you're doing the audit, the tool will figure all this out. Then we have this denial of service through XML code. Earlier, if you see this diagram, it was denial of service through putting bots on the servers and so on. This needed more work. People put firewalls, they stopped the data coming in. So now this becomes a lot easier. In fact, this is called a billion laughs denial of service attack. What happened in real life is because of all these web services and distributed servers and all objects, this DOM, dynamic object modeling, and DCOM, distributed component modeling, they have things all over the place, and these are connected up. So there is, we call this a network, or you can call it a tree diagram. So something happens as a customer, there's a address, there's a credit card, etc., whatever, all those things. Now, this is actually a geometric progression tree where somebody can, this is a genuine tree. I mean, this is from a real ERP kind of thing. I mean, web-based kind of ERP thing, enterprise software. This is a nuisance programs. What it does is, it starts when your XML parser looks at the code, it starts creating multiple insertions in geometric progression. So what they say is, even if you don't need 127 here, if you got 19, that itself is sufficient to cause a denial of service in most of the smaller web servers. You have 127, guaranteed that server is down. It keeps on creating branches and then kills the servers, become overloaded. So now we know a lot of vulnerabilities, then how do we manage these? So on the defense side, on the management side, they have said you have a lot of things. One, you manage the configuration, which is the first thing you do as an audit. You check the configuration. Then how is the authentication and authorization? We can club these together, or we can separate them, depends on the organization. Authentication is basically IAM, identity and access management. Authorization is the roles which they get, and is it like token authorized? Is like one-time authorization, so every time they get a fresh authorization, or is it like pre-configured? Then session managements are like timeouts, whether these sessions are frequently being migrated across ports to prevent these eavesdroppers, and how are the users? This mainly happens when you have large systems running on virtualization and instances are being migrated across systems. If you are dealing with these kind of headaches with your cloud service providers, they shift these actual running program instances to a different machine itself, not just the virtual instance, they shift to a different physical box. Now, there are some rules. One, the data must be in India, that is okay, they'll have a mirror server here. But this migration can be from a server in Bombay to a server in Dubai, then from there to a server in Canada, and maybe back again to Bombay or back to Singapore. You won't know it, it all happens transparently. Logs are the only way we can figure this out. Data validation, of course, whether you're getting the right data, or you saw a lot of injection possibilities, starting with SQL injection, XML injection, XPath injection. So people modifying stuff, that's the injection. So we need to check that all those, what do you call that, malicious code is all filtered out. And whenever there are errors, you saw in one of those when you had disclosure, when there was an error, instead of handling the exception, the system configuration or the details were dumped on the client side. So you have to have exception handling procedure. That's why we say corrective controls. So you kind of take some action and do something. It is not merely detective. Logging auditing, we understand. Data protection is actually, for us, it will be encryption. Storage encryption is one. Most people say my access controls are strong, so why do you have to encrypt? There are people who can actually access servers bypassing the access control. And the transit is the biggest problem. When your networks are carrying traffic, they're public networks like lease lines, or whatever, telephone lines, internet lines, whatever, service providers lines. So there it becomes very important. So just a quick look on the configuration. Okay, you look for outdated functions, etc. And you also make sure that they are not, there's no automated replication anywhere. On the authentication, of course, we are using biometrics today. Maybe passwords are still there for SQL access, from program to program access, hardware to hardware access, they still use passwords, but human you can change it to biometric. You have digital certificates, signatures, hashes, so many things are available. And also the protocols have to be fully understood, like TLS, SSL. A lot of protocols are there. We need to understand HTTPS. That's why we said port 80 or port 443. Then we have session managements. Like I've logged in, am I migrating my sessions up and down? Or there may be a company which has a 25 user database license, but they got hundreds of people using the web services. So between the web server and between the application logic server and the database server, they have only 25 connections. They bought only 25 user license. So they use a concept called pooled instances, where the 25 connections are reused with all these 100 users. So in such cases, we got to make sure that every time a connection is reused by somebody else, the session of one person, session information of one person is not moving to the other person. So that's one. And then any people stealing data, we got encryption, in transit encryption during storage. Then you also have all the validation. That's why we say sanitize all input from external sources. I mean, how heavy is it? Not very heavy today because you got parsers which check. But again, we must keep updating the list of potentially malicious code. Characters are there, but sometimes there is a combination of characters which causes trouble. And then we also say that you have a when you have a network protection of today's class is web, but even your web protection, have a deny policy, 100% denial, open only the whitelist, which means if I log into SAP, it says, it asks me for my product code or my user ID. If I don't have one, it doesn't let me inside. Bit irritating, but that's safer. Other cases, what it does is they'll have only a blacklist policy. Where only troublesome URLs and IPs are blocked. Everybody else is welcome. That is okay for a public website or a public FTP, but not for your web services which are running business logic. Logging, we understand today the word is changed to audit trails. So we need a lot of audit trails, and today they can be analyzed through Excel or some tool you can use, any data analytic tool. You can also get exceptions alone thrown to you rather than entire dashboards. And there are some, when we say do not log these, don't store them, that's what it means. There are some rules on this. Like if you're a financial institution, PCI DSS will apply. If you're working out of US, GLBA will apply. Or if you're a insurance submission provider, HIPAA will apply. So many rules are there, so we have to follow them. Then any exception or error handling should be trapped. These are called incidents. They should be trapped, they should be recorded, and the CA or whatever the auditor or whoever is there, I mean the investigator or whoever, should be able to get a list of all these incidents. You should be able to get a list of all these incidents. So that's why we say the error handling and any incident has to be strictly controlled. Okay. Then we have this data protection, which is both when it's moving from site to site or it is in transit, I mean, at rest. So we need to have all the encryption, this hashes, signatures, everything in place. There is a lot of security code given in this web services security. But then again, many companies may not, actually it's not the company's fault, it's the vendor's fault. The vendor may not be up to date. He knows his product, but he really doesn't know in the given environment how much safety is required. So then he tries to, when a security service provider is trying to sell you the security product separately, the application product person is trying to sell you the application product separately. So then if they don't match, then we don't get the output at all. Of course, SSL is the certificates for web pages. We normally check whether they are up to date. There's no negotiation of these connections. Everybody has to go to the SSL. That's called the HTTPS. You can see it on your browser. And then, of course, we say the internet service vendors will do it. or you can install it yourself also if you have your own web server. Okay, this is where all the protocols come in. I put a long list here, but it doesn't matter. There are token types, you have Kerberos, you have digital signatures on the XML object itself can be signed. You also have the certificates, the 509 certificates. That's for the LDAP. You have a lot of those facilities available. We may have to refer to some checklist, SANS or CERT or any of those will give a checklist on these security things. Okay, this is how the whole security fits in. So if you look at the bottom, we have our basic web protocol, the HTTP and the HTTPS. Then the next level, it progressed over a period of time. This XML is the ones where you put the tags for the data. And these once you create an XML object, you have the object access protocol, simple object access protocol. Then that moves on into your XML schema and gets more detailed, and it goes on and on. So it goes on like this. And then once you get into this, whatever the web security definition languages and more protocols coming in, at that point, the foundation transport invocation design is over. Then comes your actual services, the software. One is, can you identify who's logging in? Is it like MAC binding? Is it IP binding? For phones, you have to use an IMEI binding. Are we publishing things on the internet like MIS reports and those kind of things? Do we have subscription services like Reuters, Bloomberg, those kind of, many services are there. I'm just giving you some common names. Then have we got a good messaging, reliable messaging means these are not SMS messages. These are messages going from system to system, uh, giving something like wait for some time, I haven't got the data, or it's waiting in a queue. So they're called actually electronic mail message systems. Can somebody go and tamper with them? So that's the messaging part. Then we have transaction processing, and then of course we have the security part. Orchestration is a new word. It's not new, but recently it has started becoming common. It's called SOAR, SOAR. It's orchestration. And see, basically what it means is, it's basically for cyber security. This web security, the word they've changed today to cyber security. Cyber means internet, but it doesn't mean web. But most of the normal users, when we say internet, it means web only for them. So here, orchestration here means all the web tools, the encryption tools, your database security tools, your web server security tools, application security tools, all the servers, network switches, network devices, they all work together. So now that is a different concept from the earlier concept where you had a network administrator, a database administrator, etc. We had a web server administrator and so on. Now these tools are getting automated, which means once you write some scripts or give some information how to work, they just keep doing their job. And if they find anything going wrong, of course, based on how we have configured them, you will get a dashboard and the exceptions. Then, of course, comes your management and portals. We are familiar. Today, everything has gone to a portal. Everything is on a portal. Portal is basically a web page which works like a broker, connecting up to other services. Actually, the old protocol was called CORBA, Common Object Request Broker. Then that went off. We got this RMI and so on, remote method invocation and so on. That also went off. Today, we are using web portals to connect up services. So whenever you get a client software, when you get an application software, invariably the users will ask, will it work on my browser? So that's where the portals play an important part. So, just to make it clear, see, web applications and web services are not the same because an application is only the code part. I write a web page, I write a small program, I do some JavaScript or something. Web services includes servers, the diagrams you saw earlier, everything, right from the end user up to your the binaries are the web applications. Everything gets covered. So web service is a bigger thing. Then is a web service definition and security, is it sufficient to solve everything? Within this, yes, if we study all the definitions, the UDDI, the LDAPs, the SOAP, the XML, yes, that will take care of it. And XML firewalls, they'll actually, though I put this line, I just want to give you a warning. Most of these web scrubbing firewalls are software. They may not catch 100% of everything. So if you're looking at very large, complex, secure applications, after using the tools, the white box, whatever tool kind of software tool, better to do a manual walkthrough also, just to understand the code and see whether something has been missed out by the software. For instance, software will miss those two hyphens because they're comments. I mean, it's not an illegal character; it's a legal character, but being used illegally. So those kind of things, there's no software for it as yet, but we are hoping that machine learning would improve the audit tools also. Okay, this is, you integrate all this thing into your security when you're developing the application itself, web services. So one is when you're setting the requirements. When you do your threat modeling, or basically we call risk assessment. When you're doing the code reviews at different points, and when you're finally testing, you could be in all of them, or there is a big problem between consulting and assurance. So if you're on code review, or maybe if you're on penetration, you're a assurance person. So then what you did, you can, as consultant, you can't assure. But if you're a consultant, then I guess you could do all of them, but don't give any certificate on assurance. Now this OWASP, as I told you, this open web security people, every year they give, this is a 1920s or 20s anyway, past March, but they do it for an annual year. So these are the 10 top things they have done, which I put in the earlier thing also. But if you notice, this last one, in the top 10, there are hundreds of these vulnerabilities. Insufficient audit trails is there right from the 60s up to now. We said no space, can't store, etc. But today, with petabytes of storage and tons of space available, compression available, people still don't have audit trails. They don't see the importance of these audit trails. So maybe we need to educate them and do it. And the other part is this social engineering, which can happen at any point. Users getting fooled by these hacker fellows. So thank you for the time you spent, and I will now take all your questions.
Yes, sir. We have a couple of questions. I'll read them one by one. So the first question is, how can we identify a phishing page?
See, you will get this mostly from the URL. Actually, we've got a lot of examples. Actually, why it happens, I still don't know. But as I told you, this one reported case in India is the ONGC. They transferred 40 crores into some fellow sent a mail from the Gulf or something. Actually, it may not be from the Gulf. It's a fished address. So, it's a fictitious address. Fellows just used somebody's server and sent it. So ONGC got this mail, then they did nobody bothered to check the address correctly. They just thought it's coming from the vendor or supplier. So they went through their entire validation procedure. They cleared the payment. And only after they transferred it to the bank, when they didn't get an acknowledgement from the person whom they paid to, they got suspicious, called them up. Then he said, I never sent such a mail. That's a documented fraud in India. But anyway, the point is, addresses will look a little different. So if you looked at bsnl.in, bsnl.co.in, it will probably say phones dot BSNL something, or it will say BSNL dot phone something. How will you find out? You must have a list of these known addresses, and we have to find out. So that is one very important thing. It's a difficult job, but by looking at sufficient addresses, you will know the address looks fictitious.
Okay, so the next question is how to make a career in cybersecurity.
Yeah, it's see, in India we have two issues. One is the skill, the other is the certification. In India, we have some courses. There's a criminology runs a course, criminology departments of colleges. There are some colleges in Pune and so on which runs a cybersecurity course. Now, cybersecurity itself is a vague term because We need to know where we are. If you're a kind of checking software, or if you're working with an development company, then you have to study a lot of coding. Coding will be all the protocols, TCP/IP protocols, the web protocols, some syntax like PHP, Perl, CGI rules, all those things, and whatever, Java, etc. But if you're on a forensic side, then you need to understand the parts where you have to pick up sufficient evidence. So it's actually called electronic discovery. So you need to use tools like NCase and so on. You need to dump those things out, analyze that information. So at that point, you become a kind of a lawyer come technician. So you're both. You have technical skills, and the evidence must stand in a court of law because it will be cross-examined by very competent cyber lawyers. If you're an auditor, if you're trying to certify cybersecurity, then we need to learn the use of tools, because we can't be learning all this coding. And you can learn, but what I'm saying is, even without learning too much of coding, some protocols we need to learn. Safety and security standards we have to learn. There are a number of those standards. So from IEEE, from ANSI, from different people, we have got so many technical and technology committees give these standards. Then we have from the audits also, like ISACA and IA, and some standards they'll have. So those are fine. Standards are fine from the auditors, but audit firms are but the standards from the technology people we have to pick up, like W3C and those kind of people. Standards, and then we need to use the tools. I'll just quickly run through a questionnaire if you want to see it. Then I have to share the screen. Okay, maybe I'll do that after I finish the questions. So you have to decide which career you're looking at. Is it more like investigation, electronic discovery, forensic, or is it working in a software company with application security and web application security kind of? Or is it more like a consulting and an audit firm where you're more into a consulting and more of an assurance role, less of a consulting role? You probably work with the vendors and the technicians and get something done. That decision you'll have to make. Is there anything else?
Okay. Yes,
We didn't we didn't
there's
get
one more
to.
question.
Yeah.
Please tell about the relationship of web services security with the Internet of Things, big data, machine learning, robotic process automation.
Okay. Internet of Things is actually a new name. It's something they just coined, IoT. The old name is, we used to call them transducers. Actually, if you see some very old books from the mid 90s, Java has got this Gini, JINI. It's a native interface. Okay, what it meant was, we take in some machine which produces, which can measure temperature, speed, voice, some sound, something or the other, and then the electrical signal is converted to from analog to digital. The digital input is fed into the whatever the CPU or computer we're using. We write some software, analyze the signal, and process it. Early things were like a digital image processing, digital signal processing, and so on. Then devices got cheaper, they got better also. So you could now install them on motor cars, you could install them in refrigerators, vending machines, etc. Today they are so cheap that maybe an RF tag, sticker RF tag is 50 paisa or something, so it doesn't matter. So it gets very cheap. But then how much of information will it have? Maybe just as an ID number. Your credit card with a kind of a SIM card kind of facility, it carries more information. Now, if you have something which is like a newer vehicle with where the key has got all your information encoded, I mean your car key, then that's got much more information about the vehicle and the owner. Now we have got a lot of these things. Basically, all are IoTs. To give some examples, private insurance companies in India have put these IoTs, the small devices. They can look like whatever shape or size. They put them on the motorcycles of the Swiggy people. The insurance policy is, if this guy is on the route given by the Swiggy app, of course done from the server, and he has not deviated, he has not gone anywhere else. The insurance starts the moment his vehicle starts and stops when the delivery is done and he's back at the same waiting point or whatever. So there is this insurance company getting data from this IoT via satellite, or they may get it via cell phone towers, or they may get it via a GPS also. So the IoTs have become very common. In fact, your mobile phone, if you're configured it with a wearable device, the wearable is an IoT. Insurance IRD has a 10-member committee for studying of these wearables, and they want to reduce the insurance premium. So those who use these wearables, which means that even before you know you are getting a heart attack or some problem, the hospital has already been informed, the insurance company has already picked up the data. It goes to your phone, wearable to phone, phone to whoever it is, the hospital, the insurance, etc. We got a lot of those IoTs today. Is there anything else?
Yes. How can we basically protect our personal computer data from cyber or web crime?
Yeah, for personal computer data, the best is you put a antivirus and what we call an endpoint for firewall. You can get endpoint firewalls from Windows itself. Windows itself gives you a firewall. Otherwise, you can get actually, I say, generally use a lot of open source. They're quite reliable, except companies won't accept that fact, but they're quite reliable. So you can use a whole lot of open source, AVG, Avast, etc. They're all open source antiviruses. You can use open source firewalls. But if your machine is a Linux machine at home, you're probably using VMware or whatever. Linux also has a lot of open source. In fact, they have got better open source. You got IDSs also like Snort, you got Tripwire, you got a lot of things. So you can use a lot of open source. But a lot of personal computers also, people buy McAfee, they buy, I mean, you have to pay for it, but it's a paid service. Anyway, it's a choice. I mean, it's a choice, but try to have a local firewall and a local antivirus. Have both on your machine, and make sure the antivirus is also scanning your mail attachments. Yahoo scans the mail attachments. Gmail, they don't. Um, Otherwise, don't click on unknown things. It's safest. Okay, is there anything else?
Yes. What are the options available for victims of web services security?
I didn't hear it. What is it?
What
Say?
are the options? What are the options available for victims of web service security?
No, options available for?
Victims of web service security. Victims. It's like basically how can we protect our personal computer data from crime?
Yeah, that's what. Antivirus and firewall is sufficient.
Okay, okay.
And,
Uh, Maybe
and
I think they are asking about if they have got become a victim, what should they do? They should report to some cyber security cell or something
okay.
else.
I don't know about the other states, but in Tamil Nadu, you have an online page where from the police cyber security department, you can complain to the state cyber security. But you can also complain to the central government. They have that MeitY has got a web page. I don't know the link, but I can. If we search for MEITY, that's Ministry of Electronics and Information Technology. They have a cyber response team. We also have what is called the CERTIN, CERTIN .in.org. They also take these complaints. The CERT is more on the research side. Police cyber security and the central government security is more on the investigation side.
So does insurance cover this kind of losses?
It depends. If you have taken the proper insurance and we can demonstrate that we have put in the right amount of security, insurance will cover it. But they cover data theft. But if we cannot prove that we have put in the right amount of security or the right minimum security standards, they won't give insurance. Particularly if it is social engineering, where some fellow got some data from you, he made a phone call, he pretending as if he was somebody else, then the insurance does not cover it. But cyber insurance is now mainly companies take it. Individuals, I don't know. I mean, it's going to cost money for the premiums. So, anyway, that's a choice we can make.
One last question. For someone who's interested in a career in cybersecurity, what is the minimum duration he has to put in? And does Indian qualification sufficient or international certification is required?
There's no qualification.
Can he go for a job or can he start his own practice? So can you just throw some ideas on this?
For the Indian side, we have no qualification. We have no certification. We have only qualification. That is only in the law side. We have cyber law kind of schools or law colleges where they do cyber law, but that's all on the legal side. Then we have criminology departments conducting this forensic and digital forensic and so on. That is more on the you're trying to get into a software company or work somewhere. For the others, it's only a certification like CISSP or a lot of those certifications are there, which means you must already have a base qualification. So the certification alone, suppose I'm a BCom and I get this certification, unless I have tremendous amount of experience or exposure, they don't consider. So that's the problem in India is we don't have a technical thing like I mean, late in life, I want to learn these things, get myself certified, or I get a degree. There is no such option. Maybe it'll come up, but right now, there's no such thing. Even in the police department, even in the Q branch, even in MCA or ROC, so I mean, different, so many places, you will find most of them would be some engineer with some CFE, CSSP, etc. But they are not actually gone through a course where all this has been done. Right now, no university is offering it, so maybe it will come. It could take time.
Any ballpark indication of the salary range they start to as a fresher and the experienced person?
Depends where you start. If you're starting in the software company, your salary will be high because, of course, obviously they're supplying the things outside. If you start with an audit firm or a consulting firm, it will be low, but your exposure will be very wide. Now, let's say I joined a fintech company. I get a good salary, but my exposure is limited to only what they are doing. But if I join some consultant or an audit firm, some security firm, or even a law firm in cybersecurity, then my exposure is much better, but salary will be much lower, very much lower, maybe half. You'll have to work for some time, get experience, and then move to the other jobs. There's a big salary difference between corporates and consultants.
Good, sir. Thank you, sir. Nidhi, over to you.
Thank you so much. If you have,
Thank you, sir. That
okay.
was indeed an insightful session. I'm sure the participants enjoyed it as well. On behalf of Excel and Excel, I thank you for sharing your wisdom, and we are glad to have you on this platform, sir. I also thank the audience for their uh, anonymous participation and support. So our next session is on 7th of August, that is Friday, on how to build professional looking financial models by Tim Heng. Uh, for the participants watching on YouTube, do not forget to like the video and subscribe to our channel. And for more fresh talks, please be tuned. Happy weekend. Thank you. Thank you, sir, for sharing your knowledge. We are glad to have you. Thank you.
Just before we wind up, if you go to sans.org, they have a checklist on web services application security. It's a 2020 publication, so that will be useful for those who want to kind of follow up on what you heard today.
Sir, can you pronounce it?
Pardon?
Can you just pronounce once again, sir? SAN?
SANS. Or if you just share the screen, I'll just open it.
You can share, sir.
Yeah, this is the one I'm talking about. If you're looking at this SANS institute, I mean, this is a US government thing like NIST. SANS is another US government thing. It's a 2020 publication. It's a, for all of us, we could go through it. If you see the areas they have covered, See, they have covered all of these: risk assessment, authentication, authorization, access control, session management, data input validation, cross-site, whatever we did just now, all these buffer overflows, etc., they have done. And then it's followed by each is a, I mean, what's the problem statement? That's the challenge. Then what are the checkpoints? What would you check? So which apply? These are more from the audit perspective or security audit perspective. Which applications are affected? Who are the users, etc. The site will be SANS actually. If you just go to the web, you can see it. Okay, if we, I'm going to find the browser. I just open the browser and okay, I'll just open the browser. I think that.
Can I share, sir?
Yeah, 1 minute. I'll just open the browser so then I can
Okay.
show you the SANS thing. So, sans.org or okay, so okay, this is the website sans.org. Okay, so this is the website. You can get a lot of information from here on security and so on. It's sans.org. I'm not sure the page is sharing, so you just okay, now it should be shared. So this is the one I was talking about. The questionnaire is from there. Is it visible on the web page?
Yes, sir. It is visible. I have shared both on YouTube and Zoom, sir.
Very
On the
good.
chat,
Very
I
good.
have just shared.
Very good. So okay, shall then if
Thank you, sir. Once again, thank you for, and we are blessed to have you, sir. Thank you.
Thank you so much, and thank all the participants also. Thank you very much.
Thank you, sir.
Thank you.